Hi, boys and girls. My name is Miss Burr, and we are going to be doing a lesson on quadrilaterals in sports. So we're going to start our lesson with our quadrilaterals in sports pre-assessment. And I'm going to share the screen so that we can look at the pre-assessment.
Thank you.
And the first thing we're going to do is we're going to go over the standard and our I can statements going into our lesson. So our first I can statement is classifying shapes by properties of their lines and angles. The next one is I can identify lines and angles, and I can draw lines and angles. So a couple of terms that I see, and all three of these I can statements are lines and angles. Now raise your hand if you're familiar with the terms lines and angles. Awesome. Now lines and angles are two things that we use to be able to identify shapes and different characteristics of shapes. And so we're going to go and we're going to answer this first question on how do you identify, can you find a shape that you identify in sports? So if you watch sports at home with your family, or you go out and watch sports, or you play sports, what are some shapes that you can identify when you are playing sports? So I'm going to give you a moment to answer this first question here. All right, does anyone want to give me an example of a shape in a sport? Yes, Anderson.
I have two.
Okay.
When I watch basketball with my mom, there's a basketball, and that's a circle. And also, they play on a basketball court, and that's a rectangle.
Awesome. So, you are correct about a court being the shape of a rectangle. Now, a ball is the shape of a sphere. That is a three-dimensional shape, is a sphere. But if we were to make our sphere second dimensional and flat, two-dimensional, then it would be a circle. So you are correct that in a second dimension, a basketball is a circle. And if it was in third dimension, then it's a sphere, but we're just going to be talking about second dimension. And then you are correct about a court. The court is the shape of a rectangle. Awesome. So now I want you all to read some of the vocabulary terms on your pre-assessment. I want you to read the three columns. I do not know this term yet. I have heard of this term, or I am very familiar with this term. I want you to go and mark an X in the category that you associate with each vocabulary term. And then at the end, we have questions about sports, if you've ever watched specific different types of sports. I have never watched or played this sport. I would never, I would, or I love to watch this sport. I want you to go ahead and mark whichever one you're most comfortable with. All right, does anyone want to give me an example of a term that they are not very familiar with? Anderson?
I don't know what interior angles is.
Interior angles. All right, we are definitely going to talk about that today. So keep your ears open for those vocabulary terms like interior angle. Is there a term that you are familiar with? Anderson?
I know parallel.
Parallel. Can you explain to me what parallel means?
Parallel is when you have two lines and they go straight up like this or like this, but they never touch.
That is correct. They are two sets of lines that never touch, and they are side by side to one another. Awesome. All right, so has anyone watched basketball or soccer or baseball or anything? A lot of sports fans here? Awesome. So there's a lot of shapes in sports, I would have to say. So we're going to start by watching this video. This video is going to give us an introduction on quadrilaterals. I want you to open your eyes and open your ears while we watch this 5-minute video.
Now we're going to talk about quadrilaterals. Now quadrilaterals, if we look at the very definition of a quadrilateral, look at the first 4 letters of quadrilaterals, and that's quad. Quad means 4, laterals means lines. So you're talking about a 2-dimensional object shape that has 4 lines. Okay, so what you're seeing here is all different types of quadrilaterals. What is also important that is all the interior angles, when added up, and each one of these add up to 360 degrees. 360 degrees inside of a quadrilateral. That doesn't change, but there are some very important and special quadrilaterals that we're going to be talking about right now. First up is a parallelogram. A parallelogram means that both pairs of opposite sides are parallel. What that means is if these were extended on forever, they would never touch, and the same with these. Okay? It also means that both pairs of opposite sides are equal. So these 2 sides are the same length, and these 2 sides are the same length. Okay? And just like I said before, all the angles inside would add up to 360. Okay, a rectangle is a parallelogram with 4 right angles. So what that means is this line is parallel with this line, and this line is parallel with this line. But it also means that we have our 4 right angles. 1, 2, 3, 4. So that's what makes it a rectangle here. A square is a special rectangle. Again, it has the 4 right angles. It has the 2 pairs of parallel lines. But it also has all sides are congruent, are equal. That's where a square really sets itself apart as a special quadrilateral. It can also be sometimes called a rhombus, which we'll talk about in a little bit. A trapezoid is another special quadrilateral in that it only has 1 pair of parallel lines. You can notice that if we were to extend these 2 lines up, they would eventually meet at a tip where it would look like a triangle. As I mentioned a couple seconds ago, a square can also be called a rhombus. That's because a rhombus is a parallelogram with all the same sides. So that kind of defines a square other than the square has the 90-degree angles. So again, this side is parallel with this side, and this side is parallel with this side. All sides are equal. The only difference between the rhombus and the square is that a rhombus doesn't need the 90-degree angles. As you can clearly see, these angles are not right angles. Okay, so a square is just a 90-degree rhombus. Using this kind of mess.
All right. So at the bottom of your pre-assessment, we have a space for you to ask questions and take notes throughout the rest of the lesson. So if you have any questions or any concerns or anything you want to write down, there's a perfect space right at the bottom of your pre-assessment for you to do that. And I'm going to go ahead and pass out the activity sheet. And we're going to start off with this activity sheet. We're just going to talk about some key terms that we heard in the video. So does anyone remember any key terms that stood out to them within the video? Anderson?
Quadrilateral.
Quadrilateral. Good job. Did you hear a definition of a quadrilateral?
A shape that has 4 sides.
Awesome. So that is just one of the characteristics of a quadrilateral, but there are other characteristics. So a quadrilateral is a closed figure that has 4 sides and the sides do not cross. So if we have a closed figure means that all of the sides touch and there's nothing left open. So for example, this is an open figure, and this would be a closed figure. So I'm going to ask, is this a closed figure?
Yes.
Okay. Is this a closed figure?
No.
Good job. So, along with being a closed figure, a quadrilateral also has 4 sides. So, whenever we're on our page, we are going to share and write this under our quadrilateral hierarchy. You're going to write the definition of a quadrilateral, which is a closed figure with 4 sides. And we're also going to draw the shapes that are considered quadrilaterals. So, can anyone think of a shape that would be considered a quadrilateral? Anderson?
A square.
A square. How many sides does a square have, Anderson?
4.
Awesome. And is it a closed figure or an open figure?
Closed.
So is that a quadrilateral?
Yes.
Awesome. Similar to a square, we have a rectangle. The only thing that's different about a rectangle is that there's 2 sides that are just a little bit longer than the other 2, but it is still a closed figure and it still has 4 sides. Another shape that we talked about in the video was a trapezoid. A trapezoid is a closed figure with 4 sides. A rhombus is a 4-sided figure that's closed. A parallelogram is also a 4-sided figure that has 4 sides and is closed. And anything that it could be a little different, you know, as long as it has 4 sides. So all of these would be considered quadrilaterals because they are 4-sided closed figures. So you're going to go ahead and write that underneath quadrilateral. Under quadrilateral, we have 2 more shapes. A trapezoid and a parallelogram. Now, a trapezoid is unique because the definition of a trapezoid is it is a quadrilateral. So we're going to write quadrilateral underneath our trapezoid. And a trapezoid is unique because it only has 1 set of parallel sides. Now, I know we remember what parallel sides are, but just remind me one more time. Anderson?
When they don't touch.
Awesome. So there's 1 set of parallel sides. So when I draw this rhombus here, or when I draw this trapezoid, these 2 lines right here are parallel and they will never touch. That is our 1 set of parallel lines. These 2 lines right here will eventually meet and cross. So that is how we define a trapezoid. Next over here is a parallelogram. Under our parallelogram, we're also going to write quadrilateral. Now what's unique about a parallelogram is there's 2 sets of parallels. So this one will be easy to remember because the word parallel is in the name. Parallelogram. So this one has 2 sets. So if we draw our parallelogram right here, if these 2 lines went on forever and these 2 lines went on forever, they would never ever touch. So that's why we would call it a parallelogram. All right. Now underneath trapezoid and parallelogram, we have rhombus and rectangle. Can anyone tell me what might be a specific characteristic of a rhombus that we talked about in the video? Anderson?
The sides are congruent.
That is correct. So the rhombus is also a quadrilateral because it's a closed figure with how many sides?
4.
Good job. And the sides are all congruent. Now the term congruent means they are the same. So we're going to write this over here. Make yourself a side note if you need to. Now if I were to draw a rhombus, all of these 4 sides are the same. So a way that I can identify that these lines are all the same is I'm going to add a little tick mark here. And that's like a little sign that tells you that all the sides are the same length. All right, a rectangle is also a quadrilateral. And now we're going to start talking about some angles. So how many angles are in a rectangle?
4.
4, good. And how many sides if it's a quadrilateral?
4.
Good. But the thing about a rectangle is our sides don't have to be congruent, but our angles do. So these angles are going to be congruent. So a rectangle has 4 90-degree angles. So when you have a 90-degree angle, that means it is straight up and down, just like an L on your finger, and you're going to do a little mark in the corner to identify that it is a 90-degree angle. A rectangle is also an example of a parallelogram because it has 2 sets of parallel sides and they will never touch. So you can write parallelogram also underneath a rectangle. Last but not least is square, which I think we're all probably the most familiar with. Now the word congruent is going to come in handy here. And congruent means what?
The same.
The same. Good job. So all of these shapes have one thing in common, and it's that they're what? We put it on every single one.
Quadrilateral.
Quadrilateral. And the thing about a square that makes it different than all the other shapes we've talked about is that there are 4 congruent sides and 4 congruent angles. So every other shape that we've talked about has had different characteristics that we are able to use to identify the shape. A square has 4 congruent sides and 4 congruent angles. So I'm going to make a tick mark here to let you know that all 4 of these sides are the same. And I'm also going to let you know that all of my angles are the same. My angles are where these 2 lines meet. So these 2 lines are going to meet right here. That's like a close-up of my angle right in there. That's a 90-degree angle. All right. Does everyone have that copied down?
Yes, Miss Burnt.
All right. Next, we're going to talk about some triangles. So there are 2 ways that you can identify what type of triangle you have. So if I draw a triangle right here, there are 2 characteristics and ways that you're able to tell what type of triangle it is. So we can identify a triangle by its sides and by its angles. So there are 3 different types of angles, and we've already talked about one type, and what was that?
Right.
Right angle. A right angle is equivalent to 90 degrees. It will always, always, always be 90 degrees. A right angle, up and down, and a right angle will always have that little square in the corner. Now, if you're smaller than a right angle, you have an acute little triangle. Oh, he's so cute. Acute triangle. And this one does not have an exact degree because it could be 89, it could be 1, or it could be anywhere in between. The little one is acute. Okay? The big angle that is bigger than a right angle is called an obtuse angle. Big and wide, obtuse angle. And this one could be anywhere from 91 degrees to 180 degrees, all the way until it could be huge, or it could be a little bit bigger than 90. But if it's not 90 and it's bigger, then it's going to be obtuse. All right. So then you can also identify a triangle by its sides. And there's 3 different sides, 3 different characteristics for sides. So you can have an equilateral triangle. Does anyone hear a term that you're familiar with inside the word equilateral? Do you all hear anything in there?
Maybe equal.
Equal? What do you think that means? If we're talking about sides and it has the word equal in it.
The same. All the
Yep.
sides are the same.
That's awesome. So all the sides will be the same. So just like our square, we're going to leave those little tick marks in there to let us know that all of our sides are the same length. And that is an equilateral triangle. Another way you can identify is still by its sides, but this one's going to be called an isosceles triangle. An isosceles triangle is when 2 sides are equal, not all 3, but 2. And then the third way is called scaling. And that's when none of the sides are the same length. And one way you can remember this is an equilateral starts with the letter E. So we're going to draw 3 lines and they're going to be equal. Equal lengths coming out from the E. So that's how we're going to remember equilateral. Plus it has the word equal in it, okay? Isosceles, the I in isosceles has 2 marks on the outside of the I. So that's how we're going to remember 2 sides. And scaling has no sides on an S. There's no straight sides. So that's how we're going to remember that a scaling triangle has no sides that are the same length. All right, so now underneath here, we have an activity. We have 3 questions, and we're gonna go through this together. We're gonna use these clues right here that we just wrote down to help us identify our 3 types of triangles. All right, so number 1, we're going to do number 1 together, and then you're going to do number 2, and then we'll check it together, and we'll do the same thing with number 3. So number 1 is an obtuse scaling triangle. So first, what I think we should do is start out with an obtuse angle. So if we know we have an obtuse triangle, that means that one of the angles is going to be bigger than 90 degrees. So we're going to go ahead and draw our obtuse angle right here. That angle right there is larger than 90 degrees. It's larger than a right angle. And then we're going to add our third side right here. And we're going to make sure that this is an isosceles triangle because we want the first 2 lines to be the same length. So, oh, scaling. Okay. Sorry, redo. So for our number 1, it's obtuse scaling. So what we're going to do is we're going to go back and start with our obtuse angle. It doesn't matter what side, it doesn't matter what size our lengths of our legs are. And then we're going to connect it. And since we want it to be a scaling obtuse, we don't want any of our sides to be the same length because it's scaling with no matching sides and it has an obtuse angle in it. So I'm not going to mark any of these lines as congruent or the same. And it's going to have an obtuse angle in it. So this is number 1. Number 2 is a right isosceles. So we're going to start with the right angle. And how can you make your triangle isosceles? So I'm going to give you a moment. All right, does anyone have an answer for me? Anderson?
First, I started out with a right angle, and I made those two sides the same length. And then I connected them.
Okay, good. What kind of angle did you have in there?
A right angle.
Right angle, good job. And why is it isosceles?
Because the two legs are the same length.
And the third leg is not the same, or is it the same?
It's not the same.
Awesome job. Same one for the third one. I want you all to work that out yourself, and I'm gonna go ahead and write it, and we're gonna see if we come up with the same answer. For an acute equilateral. All right, go ahead and look at my picture up here. Does my picture match your picture?
Yes.
Give me a thumbs up. Awesome. So if it's an equilateral with acute angles, that means all of our angles are going to be smaller than 90 degrees. They're going to be so little and cute. And we're going to have 3 lines that are equal. So all 3 of our lines have the same length. And that's how we make an acute equilateral triangle. All right, really quickly, we're going to talk about just a few more shapes. First one we're going to talk about is a pentagon. This one kind of looks like a house. Next one is a hexagon. Anderson, how many sides does this hexagon have?
6.
6, good job. Go ahead and copy these down on your paper as well. And the last one is an octagon. Octagon kind of sounds like an octopus. How many legs does an octopus have?
8.
8. So how many sides do you think? How many sides do you think this octagon has?
8.
Awesome. Now, we have talked about prefixes before in our other classes. So the prefix of pentagon is penta. Penta means 5, and gon means, shape. So penta means 5. Does anyone know what hexa might mean?
Probably 6.
Good job. Hexa means 6. And what about an octagon?
8.
8. An octagon reminds me of something whenever I'm driving and I see a sign out there. Does anyone recognize this octagon anywhere?
Maybe a stop sign.
Yes, a stop sign is an octagon. Looks just like it, huh? All right. Now we're going to go ahead and flip to the next page. And after we just talked about all these shapes, we're going to give you a couple minutes to draw your connection between sports and quadrilaterals. So take a couple minutes, and we talked about this at the beginning. We've talked about a couple more shapes. I want you to write down a couple of shapes that you see in connection to sports. All right. So as I was walking around, I saw a couple of the same shapes. So Who can tell me where we see a circle? Circle is not a quadrilateral because it does not have 4 sides, but it is a common shape. And we see it a lot in sports because of balls. We see balls in a lot of sports. And what about this quadrilateral?
For that one, I said that you see it in the football field.
Football field. Awesome. A lot of sports have fields that are rectangles, and they are 100 yards long. They're so long. And then I also saw pentagons, which pentagons are the shape of the bases at baseball. All right, awesome. So next what we're going to do is we are going to look at our last sheet. And our last sheet has another set of questions with our terms. And this still has a couple more columns, but the columns have changed from your pre-assessment. So if you're still struggling with this term, I want you to mark it. I'm still struggling with this term. I am familiar with this term, or I am confident in my knowledge about this term. I want you to read through these really quick and see if you know more knowledge about all of these shapes and all of these terms about quadrilaterals. All right, does anyone want to share if they've made any differences within their pre-assessment and their final questions? Anderson?
Before today, I didn't know what congruent meant, but now I do.
Congruent, and congruent means what?
That it's the same.
That it's the same. Congruent is a very important term that we can use all the time, and it comes in handy whenever we're talking about shapes. Anything else? Does anyone have a term that they're still a little bit stuck on? Anderson?
Probably interior angles.
Interior angles, all right. So our interior angles, we talked about with our triangles. The word interior is just a description of angles. So like if you have someone that's an interior designer, they like to design things that go inside the house. So the word interior means inside. So the angles that are inside this triangle are the ones that help us decide what kind of triangle it is. Or if we have a rectangle, we have 4 right angles because all of our interior angles on the inside of our shape are right angles. So those are what interior angles are. We don't have any exterior angles because we're not working on the outside of the shape. All right, does anyone have any more questions? All right.